the system on button. I'm not going to download the instrument parameters because I want to actually load the right method first. So now again, I'm going to point this to the data folder. And then I'm going to look for where it says GC, 260 methods. And I want the one that says T-butyl halides. Well, I don't have a T-butyl halides 1 because apparently last year we ran N-butyl halides on this instrument. So I'm going to open up T-butyl halides 1 from a previous year, from 2017. Hopefully this will be good enough. And now I can download those parameters. The pressures change a little bit. The gauges are not that sensitive, so frequently the retention times change a little bit from year to year, which is why there are multiple years worth of methods, because we've adjusted it to fit the actual retention times. Again, 150 degrees, same column, RTX5, 15 meter by 0.25 millimeter inner diameter and 0.25 micron thickness. But for T-butyls, we're running at 40 degrees for 2 minutes because the T-butyl halides boil lower. The detector is at 200 with a range of 2, so that is the same for the column. And now we're just waiting for this detector temperature to get over 100 so we can light the detector. And you'll notice that when it got connected, this little online yellow light started flashing, which was our indication that we are now controlling the instrument by the computer instead of by the keypad. Instrument itself is about $7,500, and then the digitizing box and the software is about $8,000. So about $15,500 per instrument back when we bought these back in 2001. But nice solid metal instrument. These things are good workhorses. They've lasted very well. So now we're going to light that detector, make sure the hole's in the back. We should hear it pop. That pop is an indication that I succeeded in lighting the flame. And then just to confirm, we're going to hold this back there and make sure there's some condensate. And there's condensation on there, so we have a lit detector. This instrument now says it's ready. And given that I'm not sure what the last thing that was run on here was, I am going to free the CBM. And then I'm going to make this a lot more sensitive to make sure that I adjust the zero. So you see it's a little bit low right now. So I'm going to use the zero knob to make that baseline go up to 0. That way I'll get accurate areas. And once I have it zeroed, then I click the 0 CBM button, and that'll set it to 0. And then I can reduce the sensitivity again. So that instrument's more or less ready. And I'm going to do the same thing for this one once it hits temperature. And then we need to get our samples out of the freezer. Remember, we had our single N-butyl, right, that we ran, which we're going to run on this instrument. And then we had the two different T-butyls, the T-butyl that was run a very short time, and then the T-butyl that was run for the longer time period. So now we just need to wait for these instruments to equilibrate, and I need to go get a bottle of pentane to wash the syringe with on this instrument. Here's our little GC syringe. It's a 10 microliter syringe. Looks like it's been bent a little bit. We're going to be making 1 microliter injections. That syringe looks like it's working. And there should be a syringe at this instrument as well. Looks like it's also good. And I need a bottle of N-hexane for this one. So the N-hexane is in this cabinet. That was our solvent for the N-butyl reaction. And the pentane is over in the flame cabinet. That was our solvent for the T-butyl reaction. That'll be what we wash out the syringe with. And I don't trust the previous people that used this instrument, because I don't know who they were. So I'm going to rinse the syringe. We just rinse the syringe out and then kind of squirt it on the floor. It's important to make sure that something's actually coming out of the syringe, right? So you'll see that there's a droplet of pentane on the bench. So this syringe is actually not plugged. It's frequently the case that people plug these syringes up. If you stick it down into the drying agent, get a little drying agent in there. So that's flush that syringe nicely with pentane to make sure it's clean and ready to go. And we'll do the same for this other syringe. We'll flush it out with the N-hexane. Make sure it's clean and ready to go. And I can see the liquid coming out of that one pretty clearly. 10 microliters at a time. It'll evaporate before it hits the floor. We got our syringes ready. This one is zeroed. All we need to do is zero this one now that it's reached temperature by freeing the CBM and blowing this way up so I'm seeing a very sensitive. And that one's actually pretty close to zero. It's likely that the last thing that was run on this instrument was in fact the hydrocarbons. Yeah, it's a little off. Can tweak it just a little bit. That's down to zero, pretty much. So we're going to zero the CBM now. And then we can back off our sensitivity. Put our baseline back down at the bottom. So I'm going to turn off the camera, and we're just going to let everything equilibrate for a while, and then I'll turn it back on when we're ready to